Hi and welcome back. In this video we'll talk in more detail about the two kinds of data types in Java, primitive types and reference types. First of all, let's create a new project in NetBeans and name it primitive and reference. From the previous video you might remember that there are 8 primitive data types and potentially an infinite number of reference data types in Java. You might also remember that primitive type variables store values while reference type variables store references to objects. So when we have two int variables that store the same value and we compare them using the equality operator, the result of comparison is true. However, it doesn't seem to work the same way for string variables. Now, if the examples you see on the screen do not look familiar, please refer to the previous video before proceeding with this one. In the previous video, I mentioned that when you use the equality operator to compare reference type variables, what gets compared is the object references that the variables store. First of all, what is an object reference? An object reference is, simply put, the location of the object in computer memory. An object reference is a piece of data that helps the computer locate the object. Why would you need anything to locate an object, some of you might ask? I know that there is an object and I want to use it. Why can't the stupid computer just do as I say? Well, imagine you have a friend, Kate. You've known each other for years, you know for a fact that she exists. But if you want to call Kate, you can't just pick up a phone and call her if you don't know her phone number. In this example, Kate's phone number is the piece of data that you need to call Kate. Here's another example. Say you want to visit Kate. Well, you at least need to know her address. Otherwise, where would you go to visit her? In this example, Kate's address is the piece of data that you need to be able to visit Kate. In Java, every object has a unique reference. No two objects can have identical references, meaning if two reference type variables store the same reference, they refer or point to the same object. And if two variables point to the same object, they are considered equal if you compare them using the equality operator. And if two reference type variables point to different objects, they are not considered equal when you compare them using the equality operator. Here, string variables s1 and s2 point to two different string objects. So S1 and S2 are not equal even though the contents of the string objects that the variables point to are the same. Just like identical twins, they might look exactly the same, but they are two different people. Now, how do we get an object reference? I think it's time to make it a little bit more complex and talk about class instantiation, which, to be fair, we did touch upon in the previous videos. Some of you have probably figured that class instantiation and object creation are synonymous. When we instantiate a class, we create an object or instance of that class. So let me repeat it. When we instantiate a class, we create an instance of that class. An instance of a class is also called an object of that class. To instantiate a class, we can use the new operator followed by the name of the class that we want to instantiate. Let's take a look at this example. This code creates two instances of the string class. The first instance stores the text hello. The second instance stores no text. Now, some of you have probably figured that whatever goes inside the round brackets following the word string is the text that the string object will store. Some of you might also remember from one of the previous videos that these are called object initialization. But these are also method calls. Just take a look. There's a name followed by a pair of round brackets. Looks just like a method call. The only confusing part here is that the name of the method is the same as the name of the class. A method whose name is identical to the name of the class is called a constructor. Constructors, in a way, are similar to the main method. The main method is the entry point to a Java program. It's the first method in your program that gets called by the JVM. A constructor is the first method that gets called when the class is being instantiated. Because of this, it's said that objects are initialized inside constructors. Object initialization is basically a set of instructions that you want the computer to execute every time the class is instantiated. Constructors, just like regular methods, take parameters. Some take only one parameter, some take a few, and some take no parameters. A class can have several constructors. In this example, we call a string constructor that takes a string as a parameter, and a string constructor that doesn't take any parameter at all. In fact, the string class has a lot of constructors, some of which you can see on the screen. This means that you can create a string object using different types of data to initialize the newly created string object. Now let's get back to the question of how we can get an object reference. So one way to get an object reference is to create the object using the new operator. Here, the new operator creates a new string object, calls the string class constructor, which takes a string as a parameter, and then returns the reference to the newly created object. And here, the reference to the newly created string object is assigned to the string variable s1. So from now on, the string variable s1 stores the reference to the string object. In one of the previous videos, I said that this assignment operator assigns the newly created object to the variable and added that this is not 100% accurate. It is important to keep in mind that reference type variables do not store objects. They store object references. Here we declare another string variable s2, create another string object, and assign the reference to that object to the variable s2. Because s1 and s2 point to different objects, s1 and s2 are not considered equal if you compare them using the equality operator. However, if we assign the variable s2 the reference stored in the variable s1 and compare both, they will be considered equal because they point to the same object. Remember that in the previous video I mentioned that all classes are reference data types, but not all reference data types are classes. In addition to classes, there are other kinds of reference data types. One of them is arrays. We did use arrays in the basics of programming with C video series. So if you don't know or don't remember what an array is, please refer to that video series. So an array is effectively a collection of variables of the same type. We can have arrays of any existing data type. To declare an array, we should add a pair of square brackets following the data type that the array is going to store. For example, an int array declaration would look something like this, and a string array declaration something like this. Since all arrays are reference data types in Java, both int array and str array are variables that can store references to an int and string array object respectively. How do we create an array object? In Java, there are several ways to do that. You can create arrays with predefined and default values. For example, this is how you create an int array with predefined values 1, 2, and 3, and assign the reference to the newly created array to the variable int array. And this is how you create a string array with default values and assign the reference to the array to the variable str array. Note that when creating an array with default values in Java, you have to specify the number of elements that the array will store. Also, different data types have different default values. For all reference types, though, the default value is null. So in this example, we create a string array that stores 3 elements, each of which is null. If a reference type variable is null, it means that that variable does not point to any object. Now, why did I bring up arrays? You got it, to make it even more confusing. Now, jokes aside, I mentioned arrays to show you another difference in behavior of primitive and reference type variables. Let's declare 2 int variables, int1 and int2. Let's assign 10 to the variable int1, then assign int1 to int2, and print the values of both variables. Expectedly, we get 10 and 10. Now let's assign 15 to the variable int2 and print both again. Expectedly, we get 10 and 15. Now let's do something similar, but with arrays. Let's declare 2 int arrays, r1 and r2. Let's instantiate an int array with predefined values 1, 2, and 3, and assign the reference to this array to the variable r1. Then assign r1 to r2, and print the elements at index 0 using both variables. If you're not familiar with how array indexing works, I recommend that you refer to the Basics of Programming with C video series. Now, expectedly we get 1 and 1 printed. Let's modify the 0th element of the array using the R2 variable and print again. And somewhat unexpectedly we get 5 and 5, not 1 and 5. Why? Because when we assign R1 to R2, we make R2 point to the same array object as R1. And since both R1 and R2 point to the same array object, we can use either of the two to access and modify the elements stored in the array object. In other words, if objects were buildings, reference type variables that point to those objects would be somewhat similar to doors. You can enter a building through a door, and one building can have multiple doors, just like multiple reference type variables can point to the same object. So in our example, we use the R2 door to enter the array building. We change something inside the building, say we spill some water on the floor. When someone else enters the building through R1 door, on the floor there will be water that we spilled. So if we use R2 to modify the 0th element of the array and then use R1 and R2 to print the 0th element of the array, the printed value will be the same. Now, if instead of assigning R1 to R2, we create a new array object with the same predefined values, and assign the reference to the array object to the variable R2, then modify the 0th element of the R2 array, and print 0th elements of both, we will see that only the 0th element of the R2 array was modified, which happened because R1 and R2 now point to two different array objects. Now let's summarize what we've covered in this video. Reference type variables store references or pointers to objects. An object reference is a piece of data that helps the computer find the object. You can have multiple variables store the same object reference. If a reference type variable is null, it means that the variable doesn't point to any object. When you instantiate a class using the new operator, the reference to the newly created object is returned, and you can assign that reference to a reference type variable. When a class is instantiated, a class constructor is called. The role of a class constructor is to initialize the newly created object. Please note that if you want to assign an object reference to a variable, the data type of the variable and the data type of the object must be compatible. In other words, you cannot assign a scanner object reference to a string variable. Now, I've prepared a few questions related to the material covered in this video. On the screen you can see an example. It's a true or false question. Because in this question b is equal to 5, the answer is true. Now try answering the following questions on your own to see how well you understand the material covered in this video. Here, because we assign the variable b the value of the variable a, and then assign the value of the variable b to the variable c, both c and a store the same value, and the answer to this question is true. Here, because S1 and S2 point to different string objects, comparing them using the equality operator returns false. Here, however, because both string objects contain the same text, hi, comparing S1 and S2 using the equals method returns true. In this question, because S3 points to the same string object as S1, and the string object contains the text hi, the equals method returns true. Here, R3 points to the same array object as R1. Since the 0th elements of both R1 and R2 are equal, the answer to this question is true. In this question, because R3 points to the same array as R1, the element at index 1 of R1 is a lowercase e, not an uppercase e, and the answer to this question is false. Here, because both R1 and R3 point to the same array object, saying that R1 is not equal to R3 is false. It was a lot of theory this time, but it will be getting increasingly difficult for you to follow the contents of the subsequent videos without understanding this theory. So I do recommend that you watch this video again if something wasn't clear. And of course, refer to the previous video series if it was hard for you to follow the contents of this one. And this is it for this video. In the next one, we'll create our first program with graphical user interface. See you then. Bye.